Thank you. And welcome, everyone, and good morning. I am delighted to welcome Andrew Himes and David Victor to the stage for this conversation on embodied carbon. And I'd like to ask them to both introduce themselves and maybe tell us a little bit about their work here and what they're doing. And actually, please throw in a little bit of how did you get to this place as well.
Okay, well, I'll start. So I'm Andrew Himes, and I'm the Director of Collective Impact for the Carbon Leadership Forum, which is a nonprofit organization. Our focus is on developing the data, the underlying science, the reporting mechanisms, and the ability for building designers and engineers and real estate professionals and policymakers to drive embodied carbon, the term that we use for all of the carbon emissions associated with all of the extraction, transportation, manufacture, and then installation of materials in buildings and infrastructure projects. It was kind of a big bookkeeping term. And when we think about embodied carbon, it's one part of a larger picture. You start by wanting to know what is the entire carbon footprint throughout the lifetime of a building project or an infrastructure project in the built environment. And it turns out that for most of the last 35 years, when you think about a green building, people are really talking mainly about operational carbon or energy. And so reducing the carbon footprint of a building was all about reducing energy usage and consumption. And so about 10 years ago, I began this path that I've been on for the last decade with a woman named Kate Simonin from the University of Washington. The Carbon Leadership Forum is an attempt to bring together all of the best science and all of the best innovative solutions for reducing the carbon footprint of building materials and infrastructure projects. So what that looks like is a complicated puzzle. It's about understanding the entire life cycle of a building. It's about the operational carbon, the embodied carbon for all of those materials, and the refrigerant leakage that's inevitable, or at least up until now has been an inevitable result of having a building and running a system to run it. So when we think about the big picture, our theory of change is that, first of all, we have to start with the data and the tools and the methodology and the reporting structures and the availability of that data to report on what happens with any building in order to make it. And secondly, we have to develop policies that are highly effective at all levels of government in order to help to drive that market transformation. And finally, collective impact is about who do we need to partner with across the industry.
Thanks, Andrew.
Yeah, so I'm a professor of innovation and public policy here at UC San Diego. I think you've heard from some of my colleagues, including our chancellor, over the last few days. I sit in the policy school. I'm also in mechanical and aerospace engineering and at the Institution of Oceanography. And I run two research groups here. One, which is on the bio there, it's mainly engineering and public policy, works on how do you eliminate the emissions that cause climate change, so deep decarbonization. We're pretty good at shallow decarbonization right now, 10, 20, 30% reductions in emissions. Deep decarbonization, different story. So we work on that. And then at the Institution of Oceanography, I run a group that works on how to assess the scalability of different technologies for reversing climate change, for pulling the carbon out of the atmosphere. I guess two other things. One is you asked, how did I get here? Well, you called me up and asked me to come, so I walked across campus and here I am. So that's, once you celebrate, given all the chaos in the world these days, I'll celebrate having a pulse. And fun fact about embodied carbon, thinking about embodied carbon correctly, or embodied materials, embodied emissions, is profoundly important. Because to the extent that you believe there are gains from trade and globalization, which I guess is a kind of quaint notion these days, but it's still true, you have to get the incentives right. because otherwise people will have an incentive to hunt for ways to produce things and avoid the emissions. And so from the kind of basic economics of the problem and strategy of the problem, you got to solve this, or have direction of solution. I was part of the leadership of the Intergovernmental Panel on Climate Change, the IPCC, the group that won the Nobel Peace, shared the Nobel Peace Prize with Al Gore for work on climate science. And my interaction with embodied carbon was in the what was called AR5, the fifth assessment report that came out 2014, 2015. My team in the IPCC did the first integration of embodied carbon into the IPCC studies. So we got permission, we thought we had permission from the governments to divide the world into different categories of countries by their income classification, as is done widely in the World Bank, other institutions. And then we tracked and we showed how embodied carbon changed over time, because in the early 1990s, there was relatively little trade in embodied carbon. The United States, in fact, was a net exporter of embodied carbon because we still had a manufacturing industry, heavy manufacturing to some degree. The United States is now a massive importer. Europe has long been a massive importer. The Eastern economies, China notably, India to some degree, are massive exporters. And other materials have other patterns. The Western Hemisphere is a massive exporter of embodied water, and almonds and all kinds of other products and so on. So we put this together, and I just want to pick up on something Andrew said, which is this is on the one hand like a boring accounting problem. And embodied in the boring accounting problem are politically very, very sensitive issues. So we had these figures in the IPCC report, and then we put them in the summary for policymakers, and countries went berserk. Because whenever you start getting the accounting right, people realize that their interests are affected. And they went so berserk that actually a bunch of countries, led by Malaysia and Saudis and a bunch of others who were kind of in the slipstream, more quiet, organized and blocked literally 1/4 of all the figures that had been in the final draft of the summary for policymakers were removed from the final because they allowed us to talk about embodied carbon. Wow. Now, we then, the next month, published them all in Science magazine, so we actually got more attention for doing that, so that was fun, and spite does make the world go round. But this, I think, is why this topic is so important.
That's fantastic. We can take some credit. We had James McCarthy here, who was co-chair of the IPCC. What friend, year, yes. Mark?
I remember it, and I don't know what year it was.
I know. It was fantastic.
He and I mostly talk about fly fishing when we get together, but occasionally about climate science.
It was really fantastic, and he shared a few stories. So that goes way back at FIRE. So I think I want to just push on one more thing that you said, which was shallow and deep. So I'm not sure I know what the difference between shallow and deep is. I mean, in terms of decarbonization. Maybe just go a little deeper into deep.
Okay. Well, the metaphors are going to get twisted on themselves very quickly, but think of shallow decarbonization as doing things we already know how to do, but a little bit better. More process efficiency, slightly better tech, things like that. We do a lot of work in aviation, and in aviation, the airlines are all tripping over each other to be proud of refleeting their aircraft, airframes, so engines and aircraft, and so on. Efficiently, yeah, and then efficient flight ops. We can cut 3% off our emissions. We do a lot of work in contrail avoidance. That's a much bigger deal, but it's still a science project. So when you put all that together, what you see is basically the efficiency of these active R&D programs and deployment programs roll out about the same speed that the industry expands. And so the intensity of the industry goes down, but total emissions are flattish. Yeah. That's an accomplishment, but that's shallow decarbonization. Deep decarbonization is zero. I mean, one of the kind of geophysical facts about the core pollutant that causes long-term climate change, carbon dioxide, is what economists call a stock pollutant. It's the buildup of the pollutant in the atmosphere that causes climate, because the process of fundamentally removing it from the atmosphere is very, very long-lived. The processes are actually 10 or 12 processes. Some of them are short-lived in the ocean, some of them are long-lived. And the ultimate processes involve weathering rocks. When you're talking about weathering rocks, it's not fast. And so, in effect, this is unlike our normal pollutants, where you lower emissions and then a week later the environment's cleaner. This is more like PCBs, where you've got to stop the total flow of pollutant in the environment. So geophysically, an 85% reduction in emissions probably would stop the buildup of carbon in the atmosphere. Let's call it 100% because some countries are not going to come along. Shocker. And 0 is a small number.
Okay, got it. So I think, I've been doing this kind of stuff for about 30 years, and I do remember when the goals were all for 2020, and then they were 2030, and then they were 2040 and 2050. And the goalposts keep changing, and I've lost, I've kind of lost track. But I would like to hear from both of you on thoughts of where are we at right now? Have we made real progress? And how do we even measure that or think about that? And then what are the new goalposts? Andrew, what's your thoughts?
I guess I want to kind of riff off something that you said just a second ago. Deep decarbonization and shallow decarbonization are very, very roughly aligned with embodied carbon and operational carbon. To some degree, we relatively fully understand what it takes to make a more energy efficient system. And when it comes to the built environment, there's a whole set of things that you know everything about in order to do energy modeling of a project and really understand it. But in order to address embodied carbon or scope 3 emissions generally, you need a whole set of requirements, expectations, different types of data, and a much deeper analysis of what it takes to decarbonize an entire supply chain for multiple materials over a long period of time. So I'll just give you kind of an example of what it takes to do deep decarbonization in the market. It starts with imagine that you're an architect or an engineer and you're helping to design a new project. And it starts with being able to evaluate published environmental product declarations for specific projects at the industry level, at the company level, at the plant level, and then individual materials. Understanding the carbon footprint, having a scientific understanding of the carbon footprint of a specific material, compare it with another potential material that may be competitive with it and may solve your problem in a different way is essential. And so if you're a designer, you need a set of tools that make use of those and compare those and allow you to make decisions based on those environmental product declarations, and potentially thousands of them in a big project. Where do those environmental EPDs come from? They come from an ability by lifecycle assessment advisors and analysts to look at that entire process and assign a value. And they can only do that if there's a standard that they can develop the EPD according to. That standard is called a PCR, or Product Category Regulation, or reference. And that PCR is created by a team of experts from across the industry who are not motivated by profit for their companies, but for the good of the industry and for the sake of decarbonization. And then, and that can take a period of years. So when you think about all of those systems that go into a building, all the products that go into a building, all of the energy that's used to make all of the things that go into a building, you've got an incredibly complex challenge, right? So in some sense, the question of whether you're aiming at 2030, 2040, 2050, or 2060 is virtually irrelevant. It's a great big idea. It doesn't, in our network, we have a whole set of initiatives and commitments from the U.S. Green Building Council, the LEED standard, or from the Living Buildings Institute, the Living Building Challenge from the Internet Institute for Living Futures, or from, there's the Architecture 2030 commitment, the MEP, that is Mechanical, Electrical, and Plumbing Engineers 2040 commitment, Structural Engineers 2050 commitment, there's a landscaper's commitment, there's a contractor's commitment, and so on. The numbers don't matter. What matters is, what is the problem? How are you making specific, measurable progress in order to solve that very practical problem? Mm-hmm. And in the end, that's all that really matters.
Okay. David, what do you think?
Well, let me zoom out, because I think every industry is going through this process right now. And the good news is that you got folks figuring out what are the standards, the KPIs, and so on. That's a sign of taking a problem seriously. It's also a sign of perpetual employment for consultants, so that's not bad too. Let me zoom out to the global goals. The global goals originally were net zero emissions by 2050, which people think is roughly associated with stopping warming at about 2 degrees. It's not a perfect one-to-one because the climate sensitivity is unknown, and so it's all probabilistic. But when you start talking about, when you work probabilistic into casual conversation, people shut down. So let's call it net zero by 2050, or well below 2 degrees, which is what's in the Paris Agreement. A lot of people are excited about 1.5 degrees. The science doesn't tell us that there's any cliff that we know of. So every 1/10 of a degree that you avoid warming is a benefit. Yeah. It's not an infinite benefit, and therefore you shouldn't be prepared to pay infinite cost. By those standards, though, we're failing. And there's been a huge enterprise around this. And you know, there's SBTI and all these others who continue. I don't know what kind of crowd mania is going on here. All these folks continue to lay out all these roadmaps to 1.5 or keep 1.5 alive. Folks, it is dead. Yeah. We are through 1.5. Like, you can try and revive the horse, but it is a dead horse. We're going to blow through 2. It was inevitable. It was obvious 10 years ago we're going to blow through 2. It's just insane. Whatever these people are smoking and inhaling, I want some of that. But, and here's the progress part. 15 years ago, we were on track for 5 degrees, 6 degrees of warming by the end of the century. Now we're on track for 2.5 or 3. That's the right way to measure progress. It's against the counterfactual. We're making amazing progress with technological change. So that's great news. The other thing I'll say, the last thing I'll say about this is a whole bunch of companies and governments made wild claims, especially publicly traded firms, made wild claims about net zero. Yeah. They had no idea what they were doing, most of them. Yeah. And in almost every industry outside of pulp and paper and a couple of others, they're not going to meet them because they had no clue what they were doing. They were saying stuff, and then the CEO had to go to Davos and say something nice and have a canapé and then go home without too much criticism. So you say something nice, and then you hope nobody notices. What I hear right now is a whole bunch of folks are uncomfortable with the goals they've set, but they don't know what to do. Yeah. So this whole business of how you, I call it blinking, how do you blink from irresponsible goals? Blink responsibly, which I thought was kind of funny, and then apparently people are unhappy about that. Or how you walk back from things. Yeah. That's really, really important. And there's a whole bunch of quiet conversations, industry by industry right now, about what responsible goals look like. And what do they look like in most industries? Is they look like intensity goals or decoupling goals. Amory Levins was here earlier, and we wrote this lovely paper in the 1970s about decoupling the economy from total energy consumption. That's what we should be working on, decoupling what we care about, which is human welfare, happiness, economic output, they're not all the same thing, from emissions. Yeah. And that's a technological phenomenon, a business model phenomenon, and the more companies in our industry set goals in those terms, the more you're seeing those goals connected to things they can really do.
Yeah. I really appreciate that. I think talking with corporates on a daily basis, I feel that there's a lot of, they're all operating in the quiet corner. No one knows what to say.
They're all hoping somebody else is going to take the heat.
That's right.
First.
And but my sense is, and this is with, of course, rose-colored glasses and red frames, that, generally people are still doing the work. I think that's my sense, that companies are still doing the work, and that it's just hard to gauge the progress. I am curious about, because I'm interested in, Barrett did a really good piece on regulation and looking at some of the pressure on Scope 3 reporting. And any thoughts on how, I think companies are coming along. Very few of the Fortune 500 actually report on Scope 3, but does embodied carbon, how does it play into that?
It's got to play into that. Yeah. Some of the resistance, though, on Scope 3 is, first of all, companies, like, look at what happened to the European oil and gas companies. They made a bunch of pledges about stuff they had no clue what they were doing. Right. So they all had to walk back from them, and they got a bunch of, hate mail for that, more than hate mail. Massive devaluations, possible implosion of companies, so it's worse than hate mail.
It's worse than hate mail.
And so I think they're all learning. They need to be cautious about making pledges and things that are not inside the fence line or plausibly they have some impact on. absolutely embodied carbon has to be part of this. In some sense, the whole Scope 3 issue is an embodied carbon issue, is where do you have the boundaries around the accounting system? I do think some of the reluctance on Scope 3 reporting and goal setting is coming from a good place, which is, especially when you're a publicly traded company, you can't go out there and make claims about your emissions if you don't really know how to do the accounting. And if anything, the SEC and others, quite apart from whatever la la land is going on there now, the SEC and the other financial regulators have made it riskier for companies to do things that they don't know how to do that involve accounting claims.
Yeah. Andrew, this is a little bit of a shift, but I think I thought that, and the built environment was pretty similar in terms of transportation, that the footprint, if you looked at it. But I think you clarified that for me. Maybe just enlighten us, and how big of a problem is this when we look at all the sources of carbon?
Right. Yeah. So part of the discussion that we had was about, for example, for a lot of people, I think the assumption is that transportation is perhaps 30 or 40% of the total pie of carbon emissions, and that the building industry is probably important, but who knows? So the reality is essentially that you take there are two major materials that we use to make buildings out of: cement and steel. And those two materials taken together constitute approximately 16 or so % of all greenhouse gas emissions, just two materials. Cement by itself is about 7 or 8%. Global transportation is about exactly equal to those two materials, about 17 or so %. So so when you think about the built environment generally, all together, when you think about operational carbon, the energy used to run buildings, when you think about embodied carbon, all the materials that they're made out of, and the carbon footprint of all those materials, sum it all up, we're around 40% of global greenhouse gas emissions. So I want to kind of also think together with David about that the challenge of reporting those emissions and understanding how to mitigate them or how to alter them. And the problem, part of the problem is it's not enough to set a target. It's not enough to even to try to account for all of those emissions and then to think about practical strategies to reduce them. You have to be able to do it in a way that drives change. So just for one example, I mentioned a whole number of global commitments or programs related to reporting embodied carbon in products and materials and so on. All of the LEED standard for buildings, which now, as of about a month and a half ago, in version 5, now reports embodied carbon along with operational carbon. That's really important because the LEED standard drives a lot of our thinking about how to build buildings and how to report on them. But also the Living Building Challenge, the Architecture 2030 Challenge that was adopted by the AIA, or the American Institute for Architects, the 2030, or the MEP 2040 Challenge, Structural Engineers 2050 Challenge, and on and on. There are 13 at last count. The problem is that all of those reporting standards, all of those programs reporting data on carbon, all of them use different data standards, reported them using different tools to different databases, none of which were talking to each other. And so if you're a real estate investment trust, for example, and you'd like to do something that made sense in order to really drive down the carbon footprint of your projects, you had no way of understanding how to do that and no way to report to your shareholders on what you had actually done. So you could make any number of promises about the future, about 20, 40, 50, whatever, but you couldn't do it. So a practical response to that was we pulled all of those people into the same room in Seattle two years ago, and we all agreed we're going to create a common shared data schema that will that all of us will follow. All of us will use that data schema to organize and report our data for our projects. All of them ultimately will be using the same tool to report the same kinds of data to the same data schema, which is in the same database. And ultimately, anybody who wants to invest in a project, anybody who wants to build a project, anybody who wants to report on a project will be able to do that using a shared system.
Wow, thank you. We're just dropped below the 5-minute mark, so if you have some questions and you want to queue up, but David, are there any? I've got so many questions left, but maybe just a cut to. I think for many of us, I guess, maybe we focused on the transportation because we could make choices about what car we were going to drive. And it seems very hard as an individual, when you go out there and you're looking at homes, there's not Amory's, what was it, a house that needs HVAC has been poorly designed.
Amory's lovely place in Snowmass. And if you're ever there,
but
go
the
visit
rest of us, I don't have a house like that.
When you can grow bananas in Snowmass, you know that you've got a different house than your neighbor.
Anything we can do personally or any good success stories.
Yeah. Almost all the personal stuff is a waste of time.
Okay.
I mean, it makes people feel good. No, it's not a license to go buy surplus coal and put it in the backyard and set it on fire. It's that one of the things that makes the problem hard is that everything's about scale. Yeah. So we've got all these leaders doing stuff. Leadership's great. Leadership, when you've got a globally mixed pollutant, leadership without followership is irrelevant. Yeah. So everyone who wants to be a good leader, this is a point that I can make to many California companies. You want to be a good leader? Lovely. But if you really want to solve the problem, you got to be evaluating your actions in terms of followership, not in terms of leadership. Two things very briefly. What do we know from literature? My guess is that the transportation problem is going to be much easier to solve than the built environment, because while the infrastructure in transportation changes slowly, the entire fleet turns over every 15 to 20 years, depending. Well, some of the airplanes that you're on feels like they were there when the Wright brothers were around, but the fleet turns over quickly, and so the technological decoupling is easier. The other thing we know, one of the most profound results from literature, is an economy that decarbonizes an economy that electrifies. You start and you aggressively decarbonize the electric power system, and then you electrify as many end uses as possible. And so the success of all of us, even in the whole industry of building, depends on another industry known as electric power.
Yeah, okay.
Tom Mitchell. So to that point on how do we move, what are your feelings on architectural material that's being sort of built with that in mind? So there's a startup in the Seattle area called Ocean, and they're doing bamboo, essentially paneling, and they're using it interior for replacement of metal paneling. And they're growing the bamboo in India and building all locally in India and selling it in India. But does that move the needle, or is that still the feel good to get along type?
That moves the needle. That's actually a really interesting and very positive story. What we're talking about generally is using biogenic materials that are made out of things that are grown, to permanently store carbon in buildings and keep it out of the atmosphere. So we're talking about bamboo, we're talking about mass timber, we're talking about straw bale construction, we're talking about insulation. Fiber insulation, yeah. There's one of the past fire starter companies at this conference was a company now called Clean Fiber, which basically, when you think about newsprint as a source for making insulation, newsprint is a declining commodity. Declining in quantities, but there's another form of paper fiber that is growing in quantity, and that would be, for example, the boxes that show up on your front doorstep from Amazon or wherever. So Clean Fiber makes biogenic insulation to go into your house or into any major office building out of cardboard, essentially, with a unique process that allows them to be the only company in North America that does such a thing.
Yeah,
with a
that's
Canada
fantastic.
process.
We've got a few more people, and I'd love to get to your questions, but if you can give very quick answers. Go ahead.
Okay, Mark Mahan. We saw, Amory helped clue us in that there was some incentives from the government, and right now solar power is economically on an exponential roll itself. I do have some other stories in, let's say, concrete or other areas where A, we can smile when we leave the room today, and B, do we really need some type of governmental incentives to get the ball rolling?
Yes. So solar is the cheapest. Many places in the world is cheap today, but the reason it's cheap is a great book by Greg Nemitz with a website called How Solar Got Cheap, is because it's a global technology. So it's a story of globalization, quaint as that sounds, where the technological frontier moved literally around the world, and that's why it's inexpensive today. We have to watch out that we don't undermine that same pattern when it comes to steel and cement, which are in much earlier stages right now. They all depend on, let's call it industrial policy. Governments that are good at industrial policy are going to be doing well in this space, and governments that aren't will not.
Yeah.
Thank you.
Yeah.
And I got the hook. The quiet hook. I apologize, but thank you so much.
Great, thank you very much.